we did high-performance computing a long time ago, and in the high-performance computing area, people did parallel programming for 20 years or so. But the problem might be that you normally only teach it to master students and not to bachelor students. So the problem now is where and in which semester you should tell them about parallel programming, because normally they just learn how to program in serial and then they start to program parallel, and this might be a problem.
And I think it makes probably more sense to start with parallel programming in general, so that students get an idea of what parallelism means in general before actually starting with the term multicore. So first, once they know a bit about parallel programming, like with shared memory or distributed memory, whatever, then it makes sense to introduce them to multi-core architectures and to show them how this all fits together.
Yeah, I think it very much depends on the type of the lecture you have. I think it's the easiest way to integrate some content from outside of the faculty or from Intel. If it's very concrete, it's about software tools, or if it's about a concrete processor architecture, and that's very easy to use this as case studies. For example, in a lab course I have, it's very good to have software tools where the students can experiment with, and they see the problems you get with parallel programming. And on the other side, I'm quite sure if you talk about processors, you want to see, or the students want to see, some specific processors from a given company. And there it's really easy to insert some content from Intel, for example.
So they first get the bits of processor architectures, parallelism, serial programming, and eventually it all fits together in the long term for them.
Yeah, one issue I have with the special topic about multicore is that from a programmer side of view, it doesn't look really much different to an SMP system in the past. So from the programming side, it's already known to the HPC area quite good. And why should they cope about specific details on the architecture? There it's also interesting, after introducing the general concepts of parallelism and so on, to look what are the differences between architectures in the past and now by moving to multi-core. For example, threads can now work much more with each other and share data much faster with each other by using, for example, the shared cache. This was not possible before. And this is again a kind of advanced topic which would be put in the back of the lecture.
Yeah.
Maybe I should say something about the course, that multi-core architecture course that was already mentioned. Mm-hmm. The students just in the beginning had to learn something about computer architecture in general. Then they learned something about the specialities of multi-core processors like shared caches and things like that. And so they had the basics about the hardware. They also had some examples of current hardware processors. And then we had some theory about parallel programming, like data parallelism, task parallelism, and all those things. Also some programming patterns and those things. And when they had the basis about that, then we went into detail about message passing programming for distributed memory machines, and we went into more detail about OpenMP programming.